Before the universe burst into existence, before space unfolded and time began its steady march, there was nothing, or was there? We've all heard of the Big Bang, the great cosmic explosion that gave birth to everything we know. But that famous story begins after the opening act. What about the true prologue, the stage before the curtains of time ever rose? What existed when there was no before to speak of? Physicists tell us that time itself began with the Big Bang, that asking what happened before is like asking what's north of the North Pole. But mystics, philosophers, and even some daring scientists suggest otherwise, that beyond our concept of time lies a reality deeper, stranger, and more infinite than we can imagine. Was there a sea of quantum potential waiting for the spark? An eternal realm beyond change, or perhaps nothingness itself, not emptiness, but a fertile void pregnant with possibility. Tonight, we'll explore the theories, myths, and mind-bending possibilities of a time before time. We'll dive into ancient creation stories, cutting-edge cosmology, and the metaphysical idea that perhaps the universe has no true beginning because it never truly started at all. So take a breath, step past the boundary of time, and let's ask the question no clock can answer: what existed before existence itself? Chapter 1: The Silence Before Time. Before we speak of galaxies, or atoms, or even light, we have to speak of nothing. But this nothing is not empty space, because space itself did not yet exist. No distances, no directions, no here, no there. It is almost impossible for the human mind to picture such an absence. Every image we summon, darkness, emptiness, a black void, is already something. But before the Big Bang, there was no black, no void, there was no stage on which events could occur because the stage itself, spacetime, had yet to be built. Physicists sometimes call this state a singularity, a point of infinite density, where the known laws of physics collapse. Mystics, across cultures, might call it the womb of creation, a realm beyond form where everything exists only as potential. But was it truly nothing, or was it a kind of pregnant stillness, holding the blueprint for everything that would follow? Quantum cosmology offers one suggestion: perhaps the universe emerged from a quantum fluctuation, a random event in a timeless realm of pure probability. But if time itself had not yet begun, what could event even mean? Here is where science meets poetry. Imagine an infinite ocean with no waves, and then, without cause, a ripple appears. That ripple becomes the universe. In that ripple, the rules of reality would take shape. Time would begin, space would expand, and in an instant so brief it has no name, the cosmos would explode into being. But before that first ripple, before the first heartbeat of the universe, there was only the silence before time. Chapter 2: The Quantum Haze, when the universe wasn't yet a universe. 2.1 The Death of Cause and Effect. In our everyday world, cause and effect feel uncheckable. A glass slips from your hand, cause, it shatters on the floor, effect. Time's arrow moves forward, never backward. This is the reality our brains evolved to trust. But wind the cosmic clock all the way back, past the formation of the Milky Way, past the forging of the first atoms, past the very first second of the Big Bang, and cause and effect start to come apart at the seams. At the smallest scales imaginable, the Planck scale, 1,000,000,000,000 times smaller than an atom, space and time themselves stop behaving like a smooth fabric. They flicker, jitter, and foam with uncertainty. Physicists call this quantum foam, a restless sea where virtual particles appear and vanish in a heartbeat, where distances and durations blur into probabilities. In this haze, before and after lose meaning, events no longer line up in a neat chain. The arrow of time, so clear to us, dissolves into a whirlpool of possibility. Some physicists argue that at this level, there is no meaningful cause at all, only random quantum fluctuations, tiny accidents of nothingness that can give rise to something. In such a realm, the question, what caused the Big Bang, might be as nonsensical as asking what's north of the North Pole. Others suspect something deeper, that causality itself is a shadow cast by a timeless reality, that the Big Bang was not triggered by anything but rather unfolded as one possible branch of a greater, timeless whole. And here's the most dizzying thought. If there was no cause in the way we understand it, then perhaps the universe is not the result of something happening, perhaps it simply is. 2.2. A universe as a probability wave. In the haze before time, the universe may not have been here at all, at least not in the sense of existing in a single, fixed form. Instead, quantum theory suggests it might have existed as a probability wave, a vast cloud of all possible realities superimposed like musical notes in a cosmic chord. Imagine every possible version of the universe existing at once. Some universes with no stars, some collapsing back into nothing instantly, some with different laws of physics entirely, and among them, one branch, ours, slowly rising out of the haze. This concept comes from the wave function in quantum mechanics. In the microscopic world, particles don't have precise locations until they are measured. Instead, they are described by probabilities, by waves of possibility. Physicists like Hugh Everett have wondered, what if the entire universe began in such a superposed state? In that case, the Big Bang wasn't a single event, but a collapse of the cosmic wave function into one reality out of countless possibilities. But here's the haunting question: if the wave function contains all possibilities, where do the other universes go after ours crystallizes? Do they vanish into nothing, or do they continue, parallel, unseen, just as real as ours? This is the metaphysical razor edge of quantum cosmology, the idea that the universe you know is only one of many possible dreams the quantum haze could have dreamed. A dream that somehow, improbably, included you. 2.3. The paradox of a beginning without time. Time is slippery. It feels absolute, yet every clock, every heartbeat, every sunrise is only time as we measure it. Strip away space, matter, and change, and what happens to time? Many cosmologists believe that before the Big Bang, time itself did not exist. There was no ticking of a universal clock, no past for the Big Bang to emerge from. This is a profound paradox. How can there be a before if there is no time? Some theories bypass the problem entirely. In loop quantum cosmology, for example, the Big Bang is not a beginning at all, but a bounce, the rebirth of a collapsing universe that existed before ours in its own time. Others propose a timeless quantum state, where the universe exists in a frozen configuration until a fluctuation, a change without a before, unfolds into spacetime. Philosophers find echoes of ancient metaphysics here. In timelessness, there is no sequence, no cause, no waiting. The Big Bang becomes less of an explosion in time and more of an awakening into time. It's like asking, does a book exist before you start reading it? Yes, but the story inside has no meaning until the first page is turned. And maybe the quantum haze was the universe's closed book, every chapter already latent, every ending already written, waiting for the moment the cover was opened. Chapter 3, The Silence Before Time. Imagine the very first instant before there was an instant. Before a clock could tick, before a particle could move. Before a single wave of light could stretch into the emptiness. And before the emptiness itself could even be empty. In this strange, alien place, though it wasn't a place, the concept of before simply dissolves. There is no timeline to stand on, no past trailing behind us, no future stretching ahead. Everything you and I have ever known exists within the river of time, and here, at the threshold, we are looking into a realm where that river hasn't yet sprung from its source. Physicists have given this frontier a name, the singularity, but the word hides more than it reveals. It suggests something concrete, a dot, a speck, a point of infinite density. Yet to imagine it as floating somewhere is already wrong, because space itself had not yet unfolded. There was no there for it to exist in, no cosmic stage, no background canvas. Not even darkness, for darkness requires the possibility of light, and light had not yet been born. The singularity is not a thing you can hold in your mind. It is a limit, a cliff edge where our mathematics work perfectly right up to the brink, and then leap into meaninglessness. Beyond that brink, equations break down and language collapses into poetry. Nothing, or something else entirely. We often think of before the Big Bang as nothingness, a great void, an eternal blank. But here is the trouble. Our minds imagine nothingness as empty space. And empty space is already something. It has dimensions, it has properties, it has the ability to expand or contract. Even to call it empty means we are picturing a place where something could, in theory, exist. If the cosmos truly had no time and no space before the Big Bang, then even this mental picture of emptiness is too much. This isn't a black canvas waiting for the artist's brush, it is the absence of the canvas, the painter, the colors, and the idea of painting itself. And yet, some thinkers, ancient and modern, have suggested that this pre-time is not absolute nothing, but a kind of fertile void. A womb brimming with potential, but utterly still. Not an empty absence, but a fullness so complete that it could not remain still forever. This is the metaphysical paradox. To be truly complete might be to overflow, to burst into expression. The first tremor, in this view, the universe did not begin because something pushed it from the outside, but because the stillness itself trembled. That tremor became the expansion we call the Big Bang. The infinite density began to unfold into space. Time stretched its first second into being. Energy and matter rushed outward in a flood that would one day cool into galaxies, stars, and us. But here is where science meets mystery. Why did the stillness move at all? Why did the nothing erupt into something? In physics, the best we can say is that quantum fluctuations, unpredictable ripples in the very fabric of reality, may have sparked it. But this is still a story told in the language of time, a story that assumes the machinery of cause and effect already existed. If time itself was born at the Big Bang, then the idea of a cause before it becomes nonsensical. Asking what happened before is like asking what is north of the North Pole. The question folds in on itself, the human ache to know. And yet, we ask anyway. We can't help it. The human mind is not satisfied with the walls of its own limitations. Something in us aches to pierce the veil of that absolute silence, to imagine the unimagined. To stand in the 0 second of creation and see, even if what we see cannot be translated into thought. Religious traditions have their answers. In the Abrahamic faiths, creation begins with a divine act, let there be light. In Hindu philosophy, the universe emerges from Brahman, the infinite, unchanging reality, a cosmic exhalation followed by eventual reabsorption. In Buddhist cosmology, universes arise and dissolve endlessly with no first beginning at all. And in the Taoist view, the Tao is the nameless origin, giving birth to the 10,000 things without itself ever beginning. Modern cosmology, stripped of myth, offers models instead of metaphors. The cyclic universe in which expansion and contraction repeat eternally. The multiverse in which our Big Bang is just one bubble in an endless froth of cosmic births. The quantum creation hypothesis in which the universe spontaneously arises from a quantum vacuum, a nothing that is, in fact, a seething field of potential. But even these models eventually run into the same barrier. If every process is part of time, then time itself remains unexplained. The origin of time is the origin of everything, and perhaps the one thing our science may never truly touch. Silence as the first language. In mystical traditions, there is a quiet agreement. What lies before the beginning cannot be spoken. Not because it is forbidden, but because words are tools built for describing relationships, and in the absence of time and space, there are no relationships to describe. This is why mystics often fall into paradox. It was, and it was not. It is everything, yet it is nothing. Before the beginning, there was neither existence nor non-existence. The silence before time is not the silence of an empty room. It is the silence in which room has no meaning. And perhaps that silence has never truly gone away. Perhaps it is still here, underneath the hum of the expanding universe, the way the depth of an ocean is stillness beneath the waves. Echoes of the pre-time in us, every so often in moments of deep stillness, in meditation, in the pause between breaths, in the quiet awe of a night sky. We may feel something that does not belong to time. A spaciousness without edges, a peace without beginning or end. It is tempting to think of this as timelessness, but perhaps it is better understood as an echo of that primordial silence. A resonance from before the first second ticked. It's possible that this is why we are drawn to the question of the beginning at all, because somewhere deep inside, our being remembers. Not in words, not in thoughts, but in the quiet between them. Standing at the edge, to contemplate the silence before time is to stand at the ultimate edge of thought. On one side lies everything we know, stars, atoms, the rhythm of days. On the other lies a mystery so absolute that even calling it mystery is too much. It is the point where science must bow to philosophy, and philosophy must bow to silence. We may never know what, if anything, existed before time. But in a strange way, that may be the point. The value of the question is not in the answer, but in the way it stretches the mind, forcing us to feel the limits of our own understanding and a glimpse, if only faintly, the vastness beyond. Because perhaps the silence before time is not gone. Perhaps it is still here, the background upon which every moment is painted. And perhaps when our own personal clock stops, we will return not to darkness, not to nothing, but to that same deep stillness. Not the end, not even the beginning, but the place where beginnings themselves are born. Chapter 4, The Birth of Light. For an immeasurable expanse of time, though the word time itself was still newborn, the universe was nothing but darkness and fire. Not the gentle darkness of a moonless night, but the kind that is absolute, unbroken. Not the flickering fire of a candle, but a blinding, formless heat where light existed without a path to travel, trapped in a cosmic fog. We call this epoch the Cosmic Dark Ages, not because there was nothing, but because there was no way for light to move freely. The universe had expanded from a single point of unimaginable density into a swelling sea of hydrogen and helium. Particles swarmed and collided, yet everything was still too close, too dense, too chaotic for structure to emerge. And yet, hidden in this primordial chaos, the seeds of everything, galaxies, stars, planets, and us, were already written. The first separation, at around 380,000 years after the Big Bang, something extraordinary happened. The universe had cooled enough for electrons and protons to slow down and finally bind together into neutral atoms. This was recombination. Suddenly, photons, the particles of light, were no longer endlessly scattered by free electrons. They were free to move, and in that instant, the universe became transparent. This first light, still traveling today, is known as the cosmic microwave background. To the human eye, it would not have been blazing white but a soft glow, shifting over billions of years into the faint whisper we now detect with our instruments. It is the universe's first photograph, an afterimage of creation itself. Gravity's patient hand, but light alone does not build worlds. While photons raced outward, gravity, silent, patient, inexorable, began its work. Tiny imperfections in the early universe's density meant some regions had slightly more matter than others. These minute differences, barely 1 part in 100,000, became the seeds of cosmic architecture. Matter pulled on matter, ever so slightly at first, forming vast filaments, invisible threads that would one day anchor galaxies. It is a paradox almost too beautiful to bear. Without those early imperfections, without that cosmic flaw, nothing we know could exist. Perfection, in the physical sense, would have been sterile. It is the unevenness, the imbalance, that made life possible. The first stars ignite. Several 100 million years later, in the densest knots of this cosmic web, clouds of hydrogen collapsed under their own gravity. The pressure rose, the temperature soared to millions of degrees. And then, the first stars were born. If we could stand there, though we could not, we would witness giants unlike any that exist today. Many of them were hundreds of times the mass of our sun, burning with a furious blue light, living fast and dying young. They forged the first heavy elements in their cores, carbon, oxygen, iron, and scattered them across the cosmos in titanic explosions known as supernovae. These were not just fireworks, they were the first alchemists, turning the universe from a simple soup of hydrogen and helium into a rich chemistry set from which planets and life could one day emerge. A universe that remembers. It is tempting to think of this as the moment the story truly begins, but that is an illusion. Everything in this chapter is not the start, but the continuation of a chain of events rooted in the first instant of the Big Bang. The light we speak of is not simply illumination, it is memory. Every photon carries a record of its journey etched into its wavelength. The first light of the universe is still out there, stretched thin by cosmic expansion, whispering to us about its birth. When astronomers point their instruments to the heavens, they are not just looking outward, they are looking backward. Every star, every galaxy is a message sent long ago, still in transit. The night sky is not a snapshot, it is an archive. The metaphor of illumination, from a human perspective, the emergence of light holds a poetic resonance. It is the moment of clarity after confusion, awareness after blindness. Philosophers have long borrowed the metaphor of light for truth, wisdom, and awakening. In the cosmic story, this metaphor is literal. Before this chapter of the universe's history, there was no way for light to carry information freely. Once transparency arrived, the cosmos could finally see itself. And perhaps that is what life is, the universe finding ways to see itself more clearly. Darkness does not disappear, but there is a deeper truth. Even as the first light spread through space, darkness did not vanish. It receded, shifted, took on new forms. Much of the cosmos remains shrouded in what we call dark matter and dark energy, entities we can infer from their gravitational effects but cannot see directly. In this way, the birth of light is not the end of mystery, but its deepening. It is as if the universe said, "Here is a little clarity, but not all at once." A cosmic dawn, astronomers call this era, when the first stars and galaxies transformed the darkness, the cosmic dawn. It is the opening act of a vast and ongoing drama. Even now, the light from those earliest stars is still crossing the universe, heading toward us. When we detect it, we are not just measuring ancient photons, we are touching the edge of time itself. In the human story, dawn is always symbolic, the end of night, the beginning of possibility. But in the cosmic story, dawn is something else as well, the proof that the universe is restless, always moving from one state to another, always creating and dissolving. Closing reflection, the birth of light is not just a historical fact in the life of the universe. It is a mirror for our own inner landscapes. We, too, have our dark ages, times when clarity seems impossible, when the future is opaque. But often, if we are patient, there comes a moment when the fog lifts and something in us becomes transparent to itself. We see more clearly, not because the mystery has vanished, but because a little more of it has been illuminated. In the next chapter, we will step deeper into the cosmic architecture, how light, matter, and gravity worked together to form the first galaxies, and how those galaxies became the nurseries for the next great leap in the universe's story, the emergence of planetary systems. Chapter 5, The First Galaxies. By the time the universe was a few 100 million years old, the first light had begun to pierce the darkness, but scattered points of brilliance are not yet a cosmos. The early stars were like campfires in an infinite wilderness, their light flickering across vast gulfs of cold hydrogen gas. It would take something far grander to weave these isolated beacons into the vast structures we recognize today, galaxies. Gravity's grand design. In the quiet after the first stars were born, gravity continued its patient, unyielding work. The earliest matter had not been spread evenly. Instead, subtle variations in density, those tiny imbalances from the earliest moments, pulled on surrounding matter like gentle tugs on a cosmic net. Over millions of years, these tugs gathered gas, dust, and stars into larger and larger clusters. From these clusters, the first protogalaxies emerged, irregular, chaotic assemblies of matter, nothing like the graceful spirals or massive ellipticals we see in the modern universe. These were the rough sketches before the masterpiece. And yet, they were already alive with possibility. Galactic nurseries. Inside these first galactic structures, clouds of hydrogen collapsed again and again, birthing new stars. Some of these stars lived short, furious lives, exploding into supernovae that enriched their surroundings with heavier elements. This cycle, star birth, star death, enrichment, repeated endlessly, creating a cosmic chemistry set that grew more complex with every generation. Planets and eventually life would one day emerge from this process. But for now, the galaxies were busy with their own growth, merging with neighbors, colliding in spectacular dances of gravity and light. Collisions and creation. In the young universe, galaxies were far closer together than they are today. Collisions were inevitable. When galaxies met, they did not shatter like solid objects. Instead, their stars passed mostly unharmed, while their gas and dust were stirred into new configurations. These encounters often triggered massive bursts of star formation, lighting up the darkness with fresh waves of brilliance. Every grand spiral we see in the night sky has a history of such mergers written in its shape. Even the serene Milky Way bears scars from ancient collisions, and in billions of years it will merge with the Andromeda Galaxy in a slow, spectacular embrace. Light as a time machine. Today, when we peer through the most powerful telescopes like the James Webb Space Telescope, we can glimpse some of these first galaxies. The light we receive from them left billions of years ago when the universe was still in its infancy. They appear small, irregular, and red-shifted by cosmic expansion, their light stretched into longer wavelengths by the vastness of space-time. Looking at them is like opening an ancient diary, reading the earliest chapters of a story that is still unfolding. The spiral and the elliptical. Over cosmic time, galaxies settled into familiar forms. Some became majestic spirals, with sweeping arms of stars winding gracefully around a central bulge. These are the gardens of ongoing star formation, rich in gas and dust. Others became ellipticals, massive, football-shaped collections of older stars, often born from the mergers of spirals. Each type holds clues about its past, a history written not in words, but in the arrangement of its stars and the color of its light. The Milky Way's origins, our own galaxy. The Milky Way is the product of countless mergers and accretions. It began as a collection of smaller protogalaxies, slowly growing over billions of years. Even now, it continues to absorb smaller galaxies in its gravitational reach, a reminder that the universe's evolution is not finished. We live about halfway out from the galactic center, in a relatively calm region of one spiral arm, far from the chaotic star-forming heart. This quiet neighborhood has allowed our solar system and life to evolve undisturbed. Galaxies as islands of meaning. To the human mind, a galaxy is an almost ungraspable concept, hundreds of billions of stars, each perhaps with planets, each a potential cradle of life. Yet galaxies are not just collections of matter, they are contexts. Within them, stars and planets are born, live, and die. Without galaxies, there would be no structure, no continuity, just an endless, featureless void. In a way, galaxies are the universe's way of organizing itself. They are the sentences and paragraphs in the cosmic story. The metaphor of gathering. There is something deeply symbolic about the emergence of galaxies from scattered stars. In our own lives, we often begin in isolation, individual sparks moving alone, until something draws us together into families, communities, cultures. From the chaos of separate points, patterns emerge. The galaxies remind us that beauty often comes from gathering, from connection, from the gravity of shared existence. The ongoing dance, the first galaxies were not the end of creation, but its expansion into new complexity. Their light still travels across the cosmos, carrying with it the memory of beginnings. Each night, when we look up, we see their glow, sometimes so faint it took billions of years to arrive. That light tells us not only where we came from, but that creation is still happening right now, in countless other corners of the universe. In the next chapter, we'll move from these colossal structures to the more intimate scale, the formation of planetary systems, the cradles of worlds where, perhaps, the universe first began to wonder about itself. Chapter 6: The Birth of Planets. Galaxies provided the stage, stars were the actors. But the worlds, the places where life could dream itself into existence, were still waiting in the wings. To reach them, the universe needed a little more alchemy. The elemental inheritance, the first generation of stars, were almost pure hydrogen and helium. They had no planets because the heavier elements, carbon, oxygen, silicon, iron, did not yet exist. These elements were forged inside stars themselves in the nuclear furnaces at their cores. When these massive early stars exploded as supernovae, they scattered these new elements across space, seeding the galaxy with the raw materials for planets. Every rock under your feet, every drop of water, every breath you take is made of atoms born in ancient stars. In this sense, the formation of planets was written into the universe from the very beginning, but it could only happen after stars had lived and died. From dust to worlds, in the swirling arms of galaxies, clouds of enriched gas and dust began to collapse into new stars. Around many of these newborn stars, the leftover material formed protoplanetary disks, vast, rotating rings of dust and gas. Within these disks, tiny grains of dust began to stick together, forming clumps. Clumps became rocks, rocks became planetesimals, objects big enough for gravity to help them grow. Over millions of years, these planetesimals collided and merged, eventually forming planets, moons, and asteroids. The process was violent, full of impacts that could melt entire worlds or strip them of their atmospheres. But it was also creative, every collision shaping the future landscape. Varieties of worlds, not all planets are alike. The universe produces an astonishing diversity. Rocky planets like Earth and Mars, built mostly from heavier elements. Gas giants like Jupiter and Saturn, with thick atmospheres of hydrogen and helium. Ice giants like Uranus and Neptune, rich in water, ammonia, and methane ices. Exotic worlds with molten surfaces, diamond cores, or skies filled with metal vapor. Some orbit close to their stars, roasting under intense radiation. Others wander in the cold darkness between systems, free-floating worlds untethered to any sun. The role of chaos, planetary formation, is not a neat, predictable process. Many young systems experience gravitational chaos, planets shifting orbits, colliding, or being thrown entirely out of the system. Some stars may end up with no planets at all, while others host dozens. Our own solar system likely went through a violent youth, with giant planets migrating inward and outward, reshaping the orbits of smaller worlds. It is even possible that a whole planet once existed between Mars and Jupiter, now shattered into the asteroid belt. The Goldilocks zone, for life as we know it, one factor is crucial: the habitable zone, the distance from a star where temperatures allow liquid water to exist on a planet's surface. Earth sits comfortably within the Sun's habitable zone, but this is not a guarantee of life. Venus is also in the habitable zone, yet it is a furnace of acid clouds. Mars, on the edge of the zone, is a frozen desert. The lesson is clear. Habitability depends not just on position, but on atmosphere, chemistry, magnetic protection, and countless other factors. Moons, rings, and companions, planets rarely travel alone. Many worlds have moons, some of which may be more promising for life than their parent planets. Jupiter's moon Europa hides an ocean beneath its icy crust. Saturn's moon Enceladus sprays plumes of water vapor into space, hinting at a subsurface sea. Rings, too, are common, from Saturn's majestic bands to the faint dusty rings around small worlds. These features are often the result of tidal forces, collisions, or leftover debris from planetary formation. The story of our solar system: about 4.6 billion years ago, a cloud of gas and dust collapsed to form our Sun. The leftover material formed a disk, within which the planets of our solar system took shape. The inner region, too hot for ices, gave rise to the rocky planets Mercury, Venus, Earth, Mars. The cooler outer region birthed the gas giants Jupiter, Saturn, and the ice giants Uranus, Neptune. Countless smaller bodies, comets, asteroids, dwarf planets, also formed, many of them carrying water and organic molecules to the inner worlds. Some scientists believe that life's building blocks on Earth may have arrived this way. Exoplanets and other systems. In recent decades, astronomers have discovered thousands of exoplanets, planets orbiting stars beyond our Sun. These discoveries have revealed planetary systems stranger and more varied than we ever imagined. Some planets orbit in tight, scorching loops that take just hours or days to complete. Others follow eccentric paths that bring them from searing heat to icy cold in a single year. There are hot Jupiters, giant gas planets orbiting closer to their stars than Mercury is to the Sun, and super-Earths, rocky worlds larger and heavier than our own. The sheer abundance of planets suggests that the universe may be teeming with worlds and perhaps with life. Worlds as mirrors, planets are more than just physical objects. They are mirrors for our curiosity. Each one we discover is a reminder that our Earth, for all its beauty, is not unique. We are part of a much larger pattern, the universe's habit of turning dust into worlds and worlds into stories. The intimacy of distance. It is strange to think that the planets we see as bright points in the night sky are not close neighbors, but vast worlds separated by unimaginable distances. Yet, in cosmic terms, they are a local family, bound together by the Sun's gravity, orbiting in a slow, graceful dance. Beyond them lies the interstellar dark, and beyond that, other stars with their own families of planets. From worlds to life, planetary formation was not the end of the story, it was the beginning of a new chapter. On at least one of these countless worlds, life arose. On others, perhaps it still waits for its moment. In the next chapter, we'll explore the origins of life itself, from the chemistry of ancient seas to the possibility that we are not alone. Chapter 7: The Origins of Life. Planets are the stage, but life is the play. And the question that has haunted scientists, philosophers, and poets alike is this: how did lifeless rock and water become aware of itself? The quiet chemistry before dawn on the early Earth, conditions were both hostile and strangely promising. The young planet's surface was a patchwork of volcanic plains, deep oceans, and unstable continents. Meteorites still fell, some carrying water and organic molecules. Lightning split the skies, hydrothermal vents gushed minerals into the deep sea. It was a world without green plants, without animals, without oxygen to breathe, but it was rich in chemistry. In that restless chemical soup, something extraordinary began to happen. Simple molecules collided, combined, and formed more complex chains. Amino acids, nucleotides, lipids, the building blocks of proteins, DNA, and cell membranes appeared. Some may have been born here, others may have fallen from space, delivered by icy comets or carbon-rich asteroids. The line between geology and biology began to blur. The first cells, life as we know it, depends on three key properties: a way to store information like DNA or RNA, a way to harness energy, a boundary to protect itself, a cell membrane. At some point, perhaps in warm tidal pools or deep-sea vents, molecules formed that could copy themselves, the first primitive genetic systems. Surrounded by natural membranes, these systems became protocells. They were not alive in the way we think of life today, but they were something more than mere chemistry. They could change, adapt, evolve, and once evolution began, there was no turning back. The long age of microbes, for most of Earth's history, life was microscopic. Bacteria and archaea dominated the planet, shaping its chemistry in ways we still depend on. Some learned to use sunlight for energy, the ancestors of plants. Others found ways to breathe oxygen long before animals existed. It was microbes that oxygenated the atmosphere, turning a toxic sky into one we could breathe. This great oxidation event was not a sudden miracle, but the result of billions of years of photosynthetic life quietly remaking the planet. The leap to complexity. For life to diversify, something new had to happen. Cells had to join forces. This gave rise to eukaryotes, cells with nuclei, mitochondria, and other specialized structures. They were bigger, more versatile, and able to form multicellular organisms. With that leap, the stage was set for the great branching of life into plants, animals, and fungi. But for hundreds of millions of years, it was still a mostly microscopic drama. Life beyond Earth, the conditions that gave rise to life on Earth may not be unique. We've discovered amino acids in meteorites, complex organics on Saturn's moon Titan, and subsurface oceans on moons like Europa and Enceladus. Mars once had rivers and lakes and may have had the right chemistry for life long ago. If the laws of chemistry are universal, then perhaps the spark of life is too. And if life emerges wherever conditions allow, then the universe could be full of living worlds. From spark to consciousness, life's origin was just the first step. Over billions of years, evolution shaped beings capable of sensing, moving, learning, and eventually of asking questions about themselves. This is perhaps the most mysterious leap of all, from unknowing matter to conscious minds capable of wonder. The atoms in your brain were forged in stars, scattered across space, gathered into a planet, and shaped by life's long history into a being that can ponder its own existence. The fragility and resilience of life is both delicate and durable. Entire species can be erased by a shift in climate or a single asteroid impact. Yet life as a whole has survived cataclysms, supervolcanoes, mass extinctions, ice ages, and cosmic collisions. The lesson is humbling. Life adapts, transforms, and endures. But it also depends on rare balances, the warmth of a star, the chemistry of water, the stability of a planet's orbit. The ongoing experiment, even now, life on Earth is not finished evolving. Every species alive today is part of a continuous experiment in survival and adaptation. We are not the final product, but a moment in an unfolding story that began nearly 4 billion years ago. From cells to civilizations, the origin of life eventually led to creatures that could shape tools, language, and societies, a transformation so profound that it created a new kind of evolution, cultural evolution. Ideas now spread faster than genes. Technology reshapes environments faster than natural selection. In this way, humanity has become both a product of evolution and a force shaping it. The mystery that remains: we have theories, experiments, and evidence. But we still do not know exactly how life began. Perhaps we never will. Perhaps the answer is as much a philosophical question as a scientific one. What we do know is this: from the first trembling chains of molecules to the vast web of species today, life is the universe's way of knowing itself, one cell, one breath, one thought at a time. Chapter 8: Consciousness Awakens. Life had flourished for billions of years before the universe first looked at itself through conscious eyes. Microbes, plants, and early animals filled the oceans and lands, living and dying in cycles as old as the planet, but none of them yet knew they were alive. None could imagine the future or remember the past in the way we do. And then, slowly, something changed. The spark of awareness. In the quiet corridors of evolution, nature began experimenting with complexity. Nervous systems emerged, first as simple clusters of nerve cells, then as intricate webs capable of processing sight, sound, and movement. With every improvement, creatures could respond to their surroundings in more sophisticated ways, avoiding predators, seeking food, finding mates. But somewhere along that evolutionary climb, response became reflection. A fish avoids danger instinctively. A human asks, why is there danger at all? From senses to self, the first flickers of consciousness may have been like small lights in the dark, brief moments of awareness before fading back into instinct. Over time, those lights grew brighter, stitched together into a continuous experience of the world. The brain began to tell stories. This is where I am. This is what happened before. This is what might happen next. These were not just reactions, they were beginnings of an inner world. The birth of memory. Memory transformed life. Instead of living only in the present moment, creatures could now learn from the past. Mistakes could be avoided, successes could be repeated. Relationships could be remembered, but memory also brought the awareness of loss, of time passing, and eventually of death. This knowledge would shape how we build societies, art, and belief systems, and how we search for meaning. The social mind. No creature evolves in isolation. Early humans lived in groups, and survival depended on cooperation. This gave rise to theory of mind, the ability to imagine what another individual might be thinking or feeling. With this came empathy, but also deception. We learned not only to share ideas, but to shape them in others' minds. Communication deepened through gesture, then language, then storytelling. The explosion of imagination. Once language existed, consciousness could stretch far beyond immediate reality. We could talk about the past, imagine the future, and speculate about things never seen. A campfire became more than warmth. It became a gathering place where myths were born, where ancestors were remembered, and where the cosmos itself was woven into stories. Consciousness as an evolutionary tool. Why would nature favor consciousness? Perhaps because it allowed for flexibility. Instinct is rigid. It works until conditions change. Conscious thought, however, can adapt to new problems without waiting for generations of genetic change. The mind became evolution's fastest tool, reshaping environments and survival strategies within a single lifetime. The philosophical turn. At some point, self-awareness matured into self-inquiry. We began asking not only how to survive, but why we exist at all. This is where consciousness crosses into the realm of metaphysics, the study of being itself. We looked at the stars and wondered if they were part of us. We looked at our own minds and asked if they might be reflections of something larger. Perhaps we thought, consciousness is not just a product of evolution, but a fundamental feature of the universe. The hard problem. Even today, science can describe brain activity in exquisite detail, neurons firing, synapses strengthening, chemical messengers flowing. But no one can fully explain how this physical process gives rise to the inner experience of being. This mystery is called the hard problem of consciousness. It raises questions that blur the line between physics, biology, and philosophy. Is consciousness purely a product of matter? Or is matter itself shaped by consciousness? Could the universe be aware and we are its way of knowing itself? Consciousness beyond the individual. From one perspective, consciousness is personal. Your thoughts, your memories, your sense of I. From another, it may be collective, an interconnected web that links all sentient beings like individual drops in a shared ocean of awareness. Some spiritual traditions teach that the self is an illusion and that the truth of consciousness is universal. In this view, awakening is not gaining something new, but realizing you were never separate. The shadow of awareness. With consciousness came new challenges. We could anticipate the future and therefore fear it. We could remember the past and therefore regret it. We could imagine loss, failure, and mortality in vivid detail. Our awareness became both a gift and a burden. We sought ways to ease this burden through religion, philosophy, art, and science. The mirror of the universe, Carl Sagan once said, we are a way for the cosmos to know itself. If that is true, then consciousness is not an accident, it is the flowering of the universe's own potential. Every thought, every dream, every act of curiosity might be the universe looking in the mirror and asking, who am I? The next leap, just as single-celled life evolved into multicellular organisms, human consciousness may evolve into something greater, a collective intelligence and integration of minds through technology, or even a connection to deeper layers of reality we have yet to sense. If the universe is dreaming itself, then perhaps we are both the dream and the dreamers, shaping reality with every choice we make. Chapter 9: The Patterns That Dream Us. There is a quiet assumption we carry through life, that we are the ones doing the thinking, the perceiving, the imagining, that our minds are contained within our skulls, and that the universe exists out there, as something separate, indifferent, mechanical. But what if that is not the full truth? What if we are not in the universe, but rather of the universe? And the universe itself is the one that dreams us. The ancient Hermeticists had a phrase for this, as above, so below. They believed the same patterns that govern the smallest motions in our hearts echo in the grandest motions of the cosmos. The spiraling of a galaxy and the curling of a fern are both verses in the same cosmic poem. We are not outsiders peering in. We are verses, too. The mind beyond minds. In the 20th century, Carl Jung spoke of the collective unconscious, a vast reservoir of archetypes, symbols, and instincts that seems to belong to humanity as a whole. But Jung hinted at something even more daring, that this collective may not be bound to human brains at all. It may be the mind of the cosmos itself, flowing through us like a current. Modern physics offers strange support for this idea. Quantum entanglement tells us that particles, no matter how far apart, can remain mysteriously linked. Space itself may be less like an empty container and more like an intricate web of relationships. If the universe is indeed a kind of vast, interconnected network, then perhaps what we call thought is not local, it is ambient. We don't generate it so much as we tune into it. This reframes an old question: are we thinking beings inside a dumb universe? Or are we thought forms moving inside an intelligent one? The archetypal pulse, across time and culture, humans have been haunted by the same motifs: the hero's journey, the fall from paradise, the death and rebirth cycle. These myths repeat not because storytellers copy each other, but because they arise spontaneously from the deep structure of reality itself. If the universe is a dreaming mind, then archetypes may be the recurring symbols in that dream, the way our own sleeping minds return to familiar images, places, and events. Just as a dream can have multiple versions of the same scene, the cosmic dream may revisit the same story through different lives, civilizations, and epochs. Perhaps you have felt this déjà vu in your own life. A sensation that you are walking into a scene already known, meeting someone you've met before, or living a moment that feels pre-scripted. Maybe these are not random tricks of memory. Maybe they are echoes of the universal dream, rhyming with itself. The illusion of the separate self. If the universe is dreaming us, then the individual ego is not the ultimate truth, it is a character in the dream. Our names, our roles, our fears and desires, these are like costumes worn for a time. When the dream shifts, the costume is set aside and something deeper continues. This is not to say the self is meaningless. Just as a novel is enriched by its characters, the cosmic dream needs our unique expressions. But our mistake is in believing that the character is the author, that the little I running through the scene is in full control of the script. Mystics from Rumi to Ramana Maharshi have tried to awaken us from this illusion. They invite us to step back, to see ourselves not only as actors on the stage, but also as the stage itself and the space in which the stage exists. You are the character and the dreamer, the drop and the ocean. When the dream remembers itself, what happens when a character in the cosmic dream begins to realize they are being dreamt? In spiritual traditions, this is often called awakening, enlightenment, or self-realization. The mind ceases to see itself as a small, isolated flame and recognizes itself as part of the vast fire. Such awakenings often come with shifts in perception. A heightened sense of unity with nature and others, a softening of personal boundaries, an awareness that time feels less linear, more fluid. A peace that is not dependent on external events. If the dream is the universe, then awakening is when the dreamer turns lucid, when the dream begins to shape itself consciously. The dreamer's language. If we take seriously the idea of the universe as a living mind, then reality itself may be its language. Events, patterns, coincidences, what we often dismiss as chance, could be the syntax of a larger intelligence expressing itself through the medium of existence. Synchronicity, as Jung described, is the uncanny meeting of inner meaning and outer event. It is as if the dreamer behind the scenes leaves little markers for us, nudging us towards certain realizations. You think of an old friend and they call you the same day. You read a line in a book that answers a question you had been silently wrestling with. You step into a place and feel as if you've been guided there. Perhaps these moments are the dreamer's way of saying, yes, you're paying attention. The infinite mind and mortality. If we are part of a cosmic mind, what does this mean for death? In a purely materialist view, when the brain stops, the mind ends. But if mind is not produced by the brain, if the brain is more like a receiver than a generator, then death may be less like an extinction and more like changing the channel. The dreamer does not die when a character leaves the scene. The dream continues, perhaps in another form, perhaps in another world entirely. In this light, the fear of death softens. What we are is not erased, it is redreamt. The mystery that cannot be solved, the question of whether we live in a cosmic mind may never be settled by data alone. The mind trying to measure itself is like an eye trying to see itself without a mirror. We are participants in the mystery, not detached observers. And perhaps that's the point. The universe dreaming itself is not a puzzle to be solved, it's a dance to be joined. The goal is not to map the dream perfectly, but to wake up enough to move within it gracefully, compassionately, and consciously. As Alan Watts once said, you are an aperture through which the universe is looking at and exploring itself. Maybe the dream is not asking us to figure it out. Maybe it's inviting us to remember that we are it. Chapter 10: The Waking of the Cosmic Dreamer. There is a moment in certain dreams when you realize, this is a dream. The colors shift, the air thickens with possibility. The dream bends toward your awareness, and for a brief, luminous span, you become both the actor and the author. What if the universe itself could have such a moment? What if we, all of us, are the neurons firing in the brain of a cosmic mind? An awakening is when enough of us realize it at once. The threshold of collective awareness. Throughout human history, individuals have experienced flashes of this awakening: mystics, poets, scientists, visionaries. They come back from these moments speaking in metaphors: the drop and the ocean, the dream and the dreamer, the mirror and the face reflected in it. But what happens when awakening is not solitary but shared? When entire communities, perhaps even civilizations, begin to feel themselves as cells in a living, thinking cosmos. When science, spirituality, and everyday life stop speaking as strangers and begin to converse in the same language of interconnectedness, we stand, perhaps unknowingly, on the threshold of such a shift. Our technology has knitted the planet into an instantaneous nervous system. Our crises, climate, social, economic, have revealed that no corner of the world is truly separate from another. And in the background, questions that once lived only in temples and universities are whispered across kitchen tables and on long walks under the stars. Are we part of something that is thinking through us, and if so, what is it thinking toward? The dream becomes lucid. If the universe is dreaming itself, then human consciousness may be one of its ways of turning lucid, of seeing itself from the inside. Think of a lucid dream. Once aware, you can influence it. You can choose to fly instead of fall, to walk toward the shadow instead of running. Similarly, collective awakening may mean we begin to shape our shared reality with intention rather than fear or habit. It is here that philosophy and responsibility intertwine. If the dream is ours, then the wars, the beauty, the cruelty, and the kindness are not authored by some distant, alien force, they are us. And the moment we know this, the moment the dreamer wakes, is the moment excuses fall away. The fragile gift of awareness, but awakening is not an endpoint. It is a fragile, flickering state, easily lost in the pull of old patterns. Mystics often warn, the ego will try to claim the awakening as its own victory, turning insight into identity. This is why the dreamer's awakening must be paired with humility. To see that we are the universe looking at itself is not to declare ourselves gods, it is to realize that everything we harm in ourselves, everything we love in ourselves. The waking of the cosmic dreamer is not a trumpet blast revelation, it is a quiet, sustained remembering. The mystery that survives awakening, even in full lucidity, a dream retains its mystery. The colors may be clearer, the logic more fluid, but there is still something in it that surprises you, something you did not consciously author. So too with the universe, even if we awaken to our nature as the dreamer, the dream will still have its wildness. There will still be beauty we did not predict, sorrow we did not invite, and questions that remain unsolved. The point of awakening, then, is not to control the dream completely, but to meet it fully, without the veil of forgetfulness. An invitation, not a conclusion, and so we arrive at the final paradox. If the universe is dreaming itself through us, then perhaps the real awakening is not about escaping the dream at all. It is about loving it, its imperfections, its cycles, its ever-changing forms, because we know it is, in some mysterious way, us. This awareness transforms the way we live. Every conversation becomes a meeting of the universe with itself. Every choice becomes a note in the song the cosmos is composing. Every act of cruelty becomes a wound in the dreamer's own heart. Every act of kindness becomes a moment of self-healing. Awakening is not the end of the story. It is the moment we realize there is no end, only the dream unfolding. The final image, picture this, a vast, dark expanse. A single point of light flickers, then another and another. The lights connect, forming patterns, constellations, a living neural network stretching across the void. And slowly, the whole thing begins to shimmer as if taking a breath. In that breath is the entire history of everything, stars igniting, rivers forming, laughter spilling from human mouths, atoms colliding in the birth of new worlds, and in that breath, too, is you. You, the dreamer. You, the dreamed. Perhaps the question was never, are we living in a cosmic mind? Perhaps the question is, when will we realize that we are the cosmic mind, awake, alive, and dreaming still?